May 7th, 2026. A team of astronomers at the University of California, Davis, publishes a paper in Nature Astronomy that describes an object the laws of physics say cannot exist. Not shouldn't exist, cannot.
The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter.
A galaxy several times the mass of the Milky Way, already dead, already finished forming stars, and showing zero rotation, detected at a time when the universe was barely 1.8 billion years old. The object sits 12 billion light-years from Earth, captured in infrared by a telescope the size of a tennis court, floating at a point in space 1 million miles from home. The James Webb Space Telescope. And this galaxy, catalogued as XMM-VID1-2075, isn't just unusual. It compresses 10 billion years of expected evolution into a fraction of that time. And it's only the latest in a series of discoveries from this telescope that are systematically dismantling our understanding of how the universe works. But before we get to why this single galaxy is shaking the foundations of cosmology, you need to understand the machine that found it. Because the James Webb Space Telescope isn't just a better version of Hubble. It's a fundamentally different way of seeing the universe. And what it's been revealing since it opened its golden eye in 2022 is rewriting textbooks faster than scientists can print them. Webb doesn't see visible light, it sees infrared, the kind of light that passes through cosmic dust clouds that block every other telescope on Earth or in orbit. Its primary mirror is 6.5 meters across, made of 18 hexagonal segments plated with gold, designed to collect faint photons that have been traveling through space since the universe was in its infancy. And it sits at a point called L2, a gravitationally stable location about 1.5 million kilometers from Earth, permanently shielded from the sun by a sun shield the size of a tennis court, operating at temperatures close to absolute zero. When Webb opened its instruments and pointed them at the deep sky for the first time, astronomers expected surprises. Every new telescope finds something unexpected. That's the point. What they didn't expect was for the very first batch of data to threaten the foundation of modern cosmology. In the earliest deep-field images, tiny reddish dots began appearing. Lots of them. Dots that, when analyzed, turned out to be galaxies nearly as massive as the Milky Way, packed with mature red stars, sitting at distances corresponding to just 500 to 700 million years after the Big Bang. This was not supposed to be possible. To understand why, think about it this way. The universe is 13.8 billion years old. After the Big Bang, there was nothing but a hot, dense fog of hydrogen and helium. No stars, no galaxies, no structure, just expanding gas. For the first few 100 million years, this fog was so thick that light couldn't travel through it. Cosmologists call this the Dark Ages. Then, slowly, gravity began pulling gas into clumps. Those clumps collapsed. The first stars ignited. Those stars lived fast, died young, scattered heavier elements into space, and those elements formed the next generation of stars, which slowly assembled into galaxies. This process was supposed to take time, a lot of time. The first galaxies were expected to be small, chaotic, irregular, like construction sites, not finished buildings. Dwarf galaxies, maybe 100 million stars. Certainly not the 100 billion star behemoths that populate the modern universe. And then Webb found 6 of them, sitting in the early universe, fully formed. One of them with a collective mass 1 trillion times greater than our Sun, 10 times the size of the Milky Way. All of them dating to within the first 500 million years after the Big Bang. Erica Nelson, an assistant professor of astrophysics at the University of Colorado Boulder, and a co-author of the study published in Nature, put it simply. She said it's bananas. You just don't expect the early universe to be able to organize itself that quickly. These galaxies should not have had time to form. Joel Leha, an astronomer at Penn State and another co-author, told Scientific American that before Webb, scientists expected to find small, blue baby galaxies at early distances, objects which had just recently formed out of the primordial cosmic soup. Instead, they found galaxies that looked old, mature, red, as if they'd been aging for billions of years in a universe that was only a few 100 million years old. And the discoveries didn't stop there. They accelerated. In mid-2025, Webb identified a galaxy designated JWST-Z14-0 at a redshift of 14.32, placing it approximately 290 million years after the Big Bang. At that point in cosmic history, under standard models, there simply hasn't been enough time for gas to collapse, form stars, build heavy elements through stellar fusion, and assemble those elements into a structured galaxy. And yet, there it was. Bright, structured, staring back at a telescope that was looking deeper into time than any instrument in human history. Then, in early 2026, Webb found something even stranger. A galaxy called MOM Z14, one of the most distant objects ever observed, formed only 280 million years after the Big Bang. It was 100 times brighter than existing models predicted for a galaxy at that distance. Webb's near-spec instrument detected high levels of nitrogen within it, a chemical produced by stars going through their full life cycles and dying. But the galaxy was so young that its stars shouldn't have had time to produce nitrogen at all. The explanation scientists are gravitating toward is that the first stars in this galaxy were immense, far larger than anything in the modern universe, burning through their fuel at unimaginable rates and seeding the cosmos with heavy elements at a pace nobody thought possible. And in March 2026, Webb captured a galaxy so bright and so ancient that it should not have been visible at all. The galaxy, designated Jade's GS-Z13-1, existed during the period of reionization, when the universe was still filled with an opaque fog of neutral hydrogen that should have blocked its light from ever reaching us. And yet, Webb saw it. Clearly, unambiguously, as if the fog wasn't there. Which brings us back to the galaxy that dropped this week, XMM VID 1-2075. And this one isn't just about size or brightness. This one is about behavior. Galaxies spin. That's fundamental. The Milky Way spins. Andromeda spins. Nearly every galaxy in the observable universe rotates on a central axis, with stars tracing orderly paths around it. Over billions of years, when galaxies collide and merge repeatedly, their orderly rotation can be ground down into random, chaotic stellar motions. This produces what astronomers call a slow rotator, a massive, dead, elliptical galaxy where stars swarm in every direction instead of orbiting neatly. This process was thought to require roughly 10 billion years and dozens of mergers. XMM VID 1-2075 is already there, already dead, already non-rotating, already showing the characteristics of a galaxy that, according to every model, shouldn't exist for another 10 billion years. Ben Forrest, the UC Davis research scientist who led the study, confirmed that this was the first time such an object had been verified in the early universe, and the implications are enormous. If a galaxy can reach full structural maturity in less than 2 billion years, then the line between an embryonic universe and a structurally complete one sits much earlier than astronomers had drawn it. It changes what counts as a plausible ancestor for today's giant elliptical galaxies. It changes when the universe could first host the kinds of dense stellar systems that anchor galaxy clusters. And it changes the meaning of the word early itself. Now here's where this story pivots from galaxies to something much closer, something personal. Because Webb hasn't just been looking backwards in time, it's been looking outward, at other worlds. And what it found 40 light-years from Earth might be the most consequential discovery of all. In September 2025, a team of astronomers announced in the Astrophysical Journal Letters that Webb had detected the first tentative signs of an atmosphere on TRAPPIST-1e, a rocky, Earth-sized planet orbiting a red dwarf star in the constellation Aquarius. TRAPPIST-1e sits squarely in its star's habitable zone, the narrow band of distance where temperatures could allow liquid water to exist on the surface. Of the 7 planets in the TRAPPIST-1 system, It has long been considered the best candidate for habitability. Using Webb's NIRSpec instrument, researchers observed starlight filtering through the planet's edge during transits and detected spectral signatures consistent with a thin atmosphere containing carbon dioxide and traces of water vapor. They had already ruled out a thick hydrogen-helium primordial atmosphere, meaning that whatever atmosphere TRAPPIST-1e possesses was likely formed secondarily, through volcanic outgassing, the same process that built Earth's atmosphere billions of years ago. The challenge was immense. The TRAPPIST-1 star is a red dwarf covered in star spots that contaminate the data, masking the delicate planetary signal. For over a year, the team painstakingly corrected for stellar noise, and even after all that work, the result remains tentative. Two scenarios are still on the table. TRAPPIST-1e could have a dense atmosphere rich in nitrogen, or it could be a barren, airless rock. An additional 15 transits were observed through late 2025, and the definitive results are expected in 2026. Nestor Espinosa at Johns Hopkins University, lead author on one of the companion studies, told Scientific American that next year is going to be exciting for TRAPPIST-1e. His colleague Ryan McDonald was even more direct. He said if there is an atmosphere, we will see it. Think about what that means. Within the next few months, humanity may have confirmation that a rocky planet 40 light-years away, roughly the same size and temperature as Earth, has an atmosphere capable of supporting liquid water. Not a gas giant, not a frozen wasteland. A world where, in principle, life as we know it could exist. And this is what makes the James Webb Space Telescope unlike anything that has come before it. It's not finding what we expected. It's finding what we weren't prepared for. Galaxies that are too big, too old, too bright, and too evolved for the age of the universe they exist in. A galaxy that stopped spinning before it should have learned how to start. Stars that burned too hot and died too fast, seeding the cosmos with chemicals that shouldn't have been there yet. And a small, rocky planet, orbiting a dim red star in an unremarkable corner of the Milky Way that might have an atmosphere. The telescope's instruments are performing flawlessly after 3 years of operations, with no degradation that would limit its planned 20-year mission lifetime. Its observation schedule for the remainder of 2026 includes follow-up on every one of these discoveries. More early universe galaxies, more TRAPPIST-1 transits, a survey of Kuiper Belt objects in our own solar system, and the capacity to observe targets of opportunity, comets, asteroid approaches, supernova, anything the universe decides to throw at it. Before Webb, we had a story. The universe began 13.8 billion years ago. It expanded. It cooled. Gravity slowly gathered matter into stars, stars into galaxies, galaxies into clusters. Life emerged on at least one planet, and here we are. That story still holds, mostly. But Webb keeps finding chapters that don't fit. Galaxies that grew up too fast, stars that burned too bright, worlds that might not be as rare as we assumed, and a nagging, persistent, growing sense that the universe is not the orderly, predictable machine we thought it was. Something is happening out there that our models didn't predict. Something that was always there, always visible in principle, but that we couldn't see until we built a mirror made of gold and sent it 1,000,000 miles from home. The James Webb Space Telescope captured something that shouldn't exist, and then it captured another one, and another. And it hasn't stopped. And every time it points at the ancient universe and sends back data, the same message arrives. You don't know as much as you think you do.